Good evening, team. Welcome back. I'm Corey, and we're about to finish up day 14 of Advent of Code in Rust. Yesterday we did part 1, and it's time for part 2. If you missed any of my previous videos, check out my playlist up top for all my answers, and don't forget to like and subscribe for more videos. Let's get started. Okay, let's jump right back into day 14. So let's remind ourselves what day 14 was, and then we'll get down to part 2. So day 14, I liked the diagrams here. Day 14, the input was these vertices. They're like coordinates in a list, and they form shapes like this. And these shapes they call like rocks. And how part 1 works is a piece of sand falls, and it goes until it hits a rock, so it falls all the way to the bottom. And then the next piece of sand falls, and it falls to the left, and then the one after that falls to the right, and we keep repeating until we get a piece of sand that falls off the world entirely. And we counted how many pieces of sand that was. So this one in the example was 24 units of sand. The next one after that tumbled down to infinity. So then we simulated our puzzle input and got 961. Oof. So let's go over and look at the code for that real quick. So we'll start with our part 1 method, which is not organized well. Okay, so here's our part 1 method. So the first thing we do with our input is we parse this maze structure. And the maze has the rocks, and each rock corresponds to one line in the input, or one of these little rock structures from the example. And we parse a maze just by going over the lines and parsing the different rock structures out. We can keep going down. The parse methods aren't that exciting. The parse method for rock structure just splits apart on the dash, and then the right I have ligatures, so it becomes an arrow, and then trims the things and parses a coordinate out, and coordinate just parses by splitting a comma and grabbing things out of it. And then what we actually do with the maze is we turn it into a frame. So we have this frame that has the rocks. We make it a hash set here just for convenience, so that if we have two rocks in the same spot, they just go away. And a frame has a turn, just so we know where we're at. We didn't end up using it, but it just is nice to kind of know where we're at. And we convert from a maze to a frame just by calling this initial rocks method. And this initial rocks looks at the indices that we got in the input. So our rocks here is an iterator of indices. And then we call this method rock, so that was a little confusing. But basically we go from the vertices and we get an actual iterator over the coordinates. So instead of just having the vertices like 4984 and 4986, we actually draw the whole line of coordinates there. And we have multiple of those for the different line segments here, connecting all the vertices. So we produce that. And then that gives us the frame, and a frame basically just is a hash set of all the rocks that exist. And then we start dropping pieces of sand by calling next on a frame. So we have a piece of sand that we start at the magic 500 spot. And then we just say, okay, sand starts there, and which direction can the sand move? If the sand can go down, it does. If the sand can go down to the left, it does. Down to the right, and then if it can't go there, it can't go anywhere. So we keep going while we can move, and we keep just moving the sand. If we fall down the bottom, we could have just kept falling, or we can keep falling forever, but we don't, and we return none. This was an escape hatch for an infinite loop. But then once we found a place for the sand to fall, that's what happens at the end of the loop here. We actually make it into a rock and make a new frame and keep going. So then the part 1 answer is just make a frame and keep making frames until there's not a frame to be made. And then you just count how many times you can do that, and that works really nicely. We get 24 for our part 1. And there we go. So now let's read part 2 and see what we're gonna have to change. There we go. You realize you misread the scan. There isn't an endless void at the bottom of the scan. There's a floor, and you're standing on it. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with a y-coordinate equal to 2 plus the highest y-coordinate of any point in your scan. In the example above, the highest y-coordinate of any point is 9, and so the floor is at 11. This is if your scan contained one extra rock path. This is as if your scan contained one extra rock path, like negative infinity 11 to infinity 11. They're just saying if you were to try to parse it, it would look like this. We don't actually get this in our input though. With the added floor, the example above now looks like this. To find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to rest at the starting position, blocking the source entirely and stopping the flow of sand in the cave. In the example above, the situation finally looks like this after 93 units of sand come to rest. Using your scan, simulate the falling sand until the source of the sand becomes blocked. How many units of sand come to rest? Okay, so it's pretty similar. We have to add a floor and we have to add a new stop position. But besides that, it's not too bad, and we don't parse anything different. Part 2 just like has a different thing. It's kind of like our maze just has a variation on it. Kind of. And I think I want to keep a lot of things the same. So part 2 is going to look really similar. And let's wire up the test case for it. For part 2. Part 2 and the example is 93. Okay. So part 2, the first thing that we need to do is we need to have a maze that can have a floor at the bottom. But to do that, we're going to already have to parse the rock structures. So maybe mazes don't have a floor yet, and maybe frames do. Because that's kind of like when we can know easily. So maybe it's just that when we... Maybe we don't want to do into here. Maybe we want to be more explicit about this conversion, and we can do with floor or without floor. So let's do that instead. So let's implement something on maze. Let's write a function called toFrame without floor, and it takes a self and it produces a frame. And it's just this. This is a self. Dot initial rocks. There we go. What's wrong with this? Oh, self. It's not a self. This is a frame. And then we also then want like a function to frame with floor. And this is where we're gonna have some new logic. And this is just, we're just to do the whole thing for now. And we're gonna get rid of the into, or the from, which implied an into. So then in part 1, part 1, we're gonna do into, or like a to, I called it to frame. I don't like that. I'm probably gonna call it into, because I made it take self and it actually like goes into it. So into frame without floor for part 1. But now that we're here, let's rename this to into, yeah, because I like that better. Hop to it so that I can rename this one to, and then part 2 that we want down here is just gonna be into frame with floor. And then that's really all that we're gonna change about part 2. And then besides actually adding the floor, which we have to do, the other thing, I want to get things into code, and we already did the to-do in code. The next thing that I want to add is the stop condition. You can't, if you're here, if you're calling next immediately, if a self dot rock dot contains the sand start, then we return none. If, yeah, you can't keep going, you can't keep spitting out pieces of sand if there is a rock blocking the thing. So we return that. I think what's actually going to be nice is I think we can keep the logic around this, around not infinite looping if things fall off the map, because that just won't happen because our floor is going to be there. Oh wait, no, because I don't have I can't do a full rock floor, so maybe our frame, well, this still needs to be the case. This isn't wrong. So I think we'll keep this, but it just probably won't matter in the case of our floor. But what I kind of got out, and I didn't fully, is that I actually don't think I want to do the floor by just adding rocks to the thing. It would kind of work, but I don't know how many to add for the width, and I feel like it's just not going to be as nice as just putting a thing in place that says there's a floor. So let's just add something to frame that it can know about a floor. And it's going to be an option because we're not going to use it in the case of not having it. But there's a floor, and without floor, we do floor of none because that makes sense. And with floor, we'll give it a floor. But I don't want to do that quite yet. That's still the case there. So then how do I... Oh, okay, so next move here. This determines if where a piece of sand can keep falling. And right now it takes in the rocks from this, but I think it's actually gonna take in the reference to a frame so that I can call things on it. Then I'm just gonna do frame.rocks. And call this frame. Because this way, I'll change the call site. And now in next move, I can also easily access the floor that I just added. So yeah. Okay, so then the floor, I think I'm just gonna do the floor as the first if. So if down dot 1, because this is just it's a tuple, is greater than or equal to if, sorry, we do let some floor equal floor, and down dot 1 is greater than, oh man, is this not oh, they're unstable. Okay. So we can't, I'm gonna type this out and we can't do it in stable Rust, and I'll have to rewrite it, but that's okay. Okay, so if we let that and down dot 1 is greater than or equal to floor, then we just do a none here, I believe, and then this is an else if. But I can't do this here. So I think what I want to do is I don't actually know what I want to do here to make this happy, because I could pull something inside. Oh, two things. This needs to be framed off floor. Okay, now it's still just mad about the if let. If floor, this is down dot 1. There we go. Greater than or equal to floor. This is what I want. Return none. And I think what I do then is I just don't make this part of the chain. I just have this be a condition to return. If there's a floor and the down's gonna hit the floor, then you're done. And then you check rocks if you're not at the floor. And then I think all we have to do is implement the one to-do we have, which is this method, where we have to calculate the floor. And calculating the floor doesn't sound too bad. It's 2 plus the highest y coordinate. So let the floor, let's do max y. equal, let's do, okay. First, let's do rocks. Equal self dot initial rocks, like we have up there. This is gonna return our hash set, and then let max y equal rocks dot iter dot map. We take our coordinate and we do coordinate.1. We do the max of those. We unwrap it because we just assume there's going to be one. And then we do let floor equals max plus 2. We make a frame with rocks, turn 0, and floor. Why that order? Who knows? There we go. U64. Oh, it's an option. Yeah. We have a floor. Awesome. Okay. Cool. Awesome. That might be it. What does this want? Oh, this just wants to pass through floor. Okay. Well, first, does like old things still work? No, because we do have a move. Something's not compiling. Let's find that out. Okay, bring this to the bottom. There we go. I'm probably not trying to. I probably just want a reference. Yep, nice and easy. Okay, let's try the tests again. The example was working. My part 1. This took a while, but when I run it in release, it doesn't take a while. It just takes a second debug mode. And then let's try example part 2. Okay, we get something failing. Let's check it out. 24 versus 93. Well, that doesn't seem quite right. What's going on here? Isn't 24 the answer for part 1? Okay, so part 2 is giving me the same answer, and this does do with floor. So what's going on there? Oh, wait a second. I have lowest rock Y. That's happening before the floor because I didn't think to do it that way. That's totally fine. Lowest rock Y. Let floor addition. No, let's just add something to the bottom of this. So lowest rock Y plus 5. What if I just do that? Kind of cheated a little bit. That shouldn't have broken this one. Might make this one just a tiny bit longer, take longer, but I kind of doubt it. It should be about the same. Close all these windows. Okay, now let's try this one. There we go. That passed. Awesome. Okay, so the problem just was that I was hitting this lowest rock Y before floor, and I wasn't supposed to. I was thinking I was going to hit floor first. And the floor stuff happens in next move. Okay, but lowest rock Y now isn't a great name. It's like, and it's also the highest number, so let's do it as highest, point, possible. And then this 5 really wants to be named something, so let's make a const of, what do we want to call this? This is like, distance after highest point to consider before the infinite void. I think these are U64s. There we go. What a good constant name. Okay, so then all these tests should still pass, I think. There we go. Awesome. Okay, let's see if it works for part 2. My input. Part 2. This one could take... Oh, this is still named the same. This could take a bit longer. Could run it in release mode if it takes a little too long. Also, we expect the test to fail. Okay, I'm getting a little impatient. I think I want to run it in release mode. Cargo test release. Okay, so part one, the example, and part one ran pretty instantly in release. So I kind of thought part two would run pretty quickly in release. It's taken a little longer. I'm gonna give it a second. I hope it's not infinite looping, because that would be unfortunate. And I did expect it to take longer, but I didn't really expect it to take this longer. So if it's taking this long, I might need to try to figure out some tricks to make it faster. But let's add some debugging to make sure it's not in an infinite loop, because that would be unfortunate. Okay, so let's do something silly. Like, I just want to make sure we're not doing like the same thing all the time. Let's just add a debug here for self. So we're in the sand next move, and I just want to like see what coordinates we're encountering. And I want to do it just for the one test that we want to run. So things are happening, right? The numbers are definitely changing. Doesn't really seem like we're hitting a point where we're just looping necessarily. Okay. Interesting. So let's get rid of that debug. And let's go down to well, not down. Let's go up to frame. Let's go to the two implementations. This impl with the next method. This is what I want to see. Okay, I want to actually see the next method. Oh my gosh, what's happening? Okay, we're here. Okay. Here I can debug the self.rocks.length. I want to see how many rocks we have by the end here. Lots of rocks, and of course we're adding a new rock each time, which makes a lot of sense. Yep, like, makes sense. Oh yeah, I don't think the output's captured when I run it this way. Okay. So you know, it's going. The numbers aren't looping, but I might need to try some tricks. Okay, so one thing that I know is gonna be slow is that I have in the sand next move, it just goes down. Like, it doesn't do anything smarter to try to find a place to go to. It just like keeps looping, you know, and just trying to go down one at a time. Is there a way to make it better? Well, not how I have it with the rocks, right? With just a hash set of rocks, this is probably the best I can do. If I want to think of these as like lines, then I could do it that way. And that would probably be faster. But that would be like a pretty significant refactor to what I have. But I guess I don't know if I think there's a huge option. Just because I don't really know what else I think I can do to make it like substantially faster. This is also, I'm repeating this in two places, but one's before I have the frame and one's here. Don't know what to do about that. Think I'm just gonna leave it for the moment, but it's not my favorite. Okay. Yeah. And then like, how do I cargo test no capture standard out? I think there's a way to do this. Okay, so I do like cargo tests and then no capture after. There we go. Okay, yeah, see, so in release mode, we go a lot faster and we get into the tens of thousands relatively quickly. And it's hard, like the number for the first one wasn't like this, like it was 961. But we're still placing pieces of sand, I think. We've placed that many pieces of sand so far, up to 20,000. What do we want to do? I think the best bet is to try to move to something that where the frame knows about the lines too, right? Where this is just one representation. Oh, wait. We might have waited long enough. It took 1 minute to run. But it did give an answer. 26375. 26375. That is the answer. Okay, so that does solve it. And let's change this over. 26375. It works, but if I don't run it in release mode, it's going to take a long time. And if I run it in release mode, oh, well, it took 60 seconds with the debug in there. So let's remove the debug. Knowing it took a whole minute, and if I just let it run for a minute, it should return again. And this time it should work because I plugged in the right answer. Okay, so we're going to let it run. We're going to see how long it actually takes in release mode without spamming standard out. And then we might see if we can refactor it to make it faster, because that's a little too long, I think. But I do think to do anything different, I'm going to need to talk about lines and not about just rocks. I'm going to need to talk about lines for the finding a spot to go. But once I have things on top of my lines, it's just going to be back to rocks. I'm actually not a lot sure what I can do to make it significantly faster without being significantly more complex. Because I can do the line thing, but then I just have to go from the line and keep going up, right? And like that doesn't seem necessarily any better than just doing the stacking that I'm doing. Okay, well, there we go. It took about a minute again. Oh, that's funny. The standard out didn't seem to do much of anything to the difference there. Which I guess makes sense. We're doing enough of processing. That wasn't the slow part. I don't know. That's interesting. I expected it to take a bit of time. But there we go. So that's the answer, but I don't know if I have an easy thought to make it faster. Like, it's definitely in the logic of doing this loop here, right? So this is a hash set, so the contains is going to be as quick as is reasonable. We don't have a vector, so we already have that optimization. The next move for a piece of sand here is going to... Ooh, you know what would be fun to do, potentially? We could try to profile this and see what we're spending time on here. And then that would hopefully maybe give us something to optimize. But either way, I think we can take a look at it. I'm not sure if I want to do the profiling right now. But that is what we really would want to do here if we want to make this faster and we can't see anything that we think would make it faster. And we don't want to change the algorithm a lot. If we just want to like make it directly faster, profiling is probably the way to go. This is kind of gonna get called a lot, right? But it could change, so it's like not awful to do. But we could also just do it a different way a little bit. We could just keep it as a cache kind of thing. Not sure about that. Yeah, I'm not really sure if I see anything, like, because I can keep it as the lines, and then I could say when a thing falls, go down until you have a line, but then I'd have to keep going up until I found a spot that wasn't a piece of sand there. And then doing the left and right just feels weird. Yeah. This might be where we're going to leave it. It runs in a minute in release mode in Rust, which isn't bad. It's one reason where we're probably really happy that we chose Rust as the language here. And actually, we're really happy that we made this a hash set here, where the frame rocks are not a vec of coordinates. They're a hash set. Because I think this would be worse if it wasn't that. And then it made it easy to not have to figure out the sizing correctly of like a coordinate grid. Yeah, that might be it. I'm not sure I'm gonna make it a ton faster right now. I'm not coming up with any great tricks, so I think we're gonna leave it there. We did get part 2 solved, and it only takes a minute to run, so I'm gonna be happy with that. Thank you, and I hope you enjoyed the video. I will be back with day 15 here shortly. Thanks. Bye.